In today's class, we'll be working on Pythagoras Theorem and its application. First, I'll explain the statement of Pythagoras Theorem. Then, we'll find out some important numbers which satisfy the theorem. They are called Pythagorean triples. These are the numbers. After knowing this, we'll be working on previous SSC CGL questions and IBPS PO questions. Are you ready for this? Let's begin. Pythagoras Theorem. In a right-angled triangle, if one of the angle of the triangle is 90 degrees, it is called right-angled triangle. In a right-angled triangle, the longest side is called hypotenuse. Statement of theorem. In a right-angled triangle, square of the longest side, that is, longest side is hypotenuse, square of the hypotenuse is equal to the sum of the squares of the other two sides. That is statement of theorem. For our better understanding, let's work with the diagram. Let's call this vertex A, and this is B, and this is C. Let's move back to the statement. In a right-angled triangle, that means in the triangle, if one of the angle is 90 degrees, it is called right-angled triangle. The square of the hypotenuse means square of the longest side, AC square, is equal to the sum of the squares of the other two sides, meaning AB square plus BC square. Now let's find out those numbers which satisfy this equation. Let's start with 1 square. 1 square is 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 35, 6 square is equal to 36, 7 square is equal to 49. Okay, let's work with 13 square. Write 3 square on the opposite. 3 square is 9. Now multiply 3 with 2. 3 to 6. That's 1. Similarly work here. 2 square is 4. Root 2 is 4. 1. Okay, 4 square is 16. 1 in hand. 4 to 8. 9. 1. 5 square is 25. 5. 2 in hand. 5 to 10. 11, 12. 2, 1 in hand. 1 with in hand. 2. 6 square is 36. 3 in hand. Multiply this with this. 6 to 12, 13, 14, 15, 5, 1 in hand, 1 within hand, 2. 7 square, 4 to 9, 9, 4 in hand, 7 to 14, add with this, 18, 8, 1 in hand, add this with in hand, 2. In this square, 2 square is 4 with 2 zeros. Okay. How to find the square root of 23? Square root of 3 is 9, right? As 2 is number. Square root of 2 is 4, right? As 2 is number. Multiply this and this. 3 to our 6. With the answer, multiply the 4. 6 to our 12. Add this. 9, 2, 5. This gives the value of 23 square. 4 square is 16. 2 square is 4. Multiply this and this. 4 to our 8. With this answer, multiply this. 8 to our 16. Add this 2. 6, 7, 5. 2 into 3. 6, 2, 5. Now, among these numbers, let's find out those numbers which satisfy this equation. Let's check this two number. Add this two number. 9 plus 16, that is 25. These three numbers satisfy this equation. Let's write down. 3, 4, 5. What else? Let's add this and this. 5 plus 4, 9. 2 plus 4, 6, 1. Now, one more number, that is 5, 12, 13. What else? 7, 24. 9 plus 6, 5. 15, 1 in hand. 4 plus 7, 11 in hand. 12, 6. That is 7, 24, 25. Add this and this. 4 plus 5, 9. 6 plus 2, 8. Now 2. 8, 15, 17. There are many more numbers which satisfy this equation, but we have learned about a few of them which are commonly asked in any competitive exam. These are some of the common triplets or triples which you have to learn by heart. Before we solve this problem, first let's understand what is radius of the circle and chord of the circle. Let's draw a circle. This is the center of the circle. Draw a straight line. If this end points of this straight line lies on the circumference of the circle, it is called chord of the circle. What is circumference of the circle? Measure from here. When you complete one rotation, it is called circumference of the circle. If the end points of a straight line, these 2 points, lies on the circumference of the circle, it is called, this is called chord. Take any point on the circumference of the circle and join that point with the center of the circle. This is called radius. Okay, I'll take point here. Join this point with the center of the circle. This is called radius of the circle. Now take midpoint of this chord. Join this midpoint of the chord with the center of the circle. This is the distance of a chord from the center of the circle. In a circle of radius 30 centimeter, this is radius, this is 30 centimeter. A chord is at a distance 12 centimeter, this is 12 from the center of the circle. What is the length of the chord? Now check here. We have 12, 13. 12, 13. Missing number is 5. Therefore, this must be 5. This is 5. If this is 5, this must be equal to 5. Chord of a circle is 5 plus 5, that is 10. In a circle of radius 13 centimeter, radius means this is 13. A chord is at a distance of 5 centimeter. This is 5 from its center. What is the length of the chord? Length of the chord is this value. 5, 13. Missing number 5, 13. 12 is the missing number. Right, 12 here. If this value is 12, this must be also 12 because this point is the midpoint of the chord. Length of the chord is 12 plus 12, 24. The right answer is 24. Okay, now let's solve the next question. In a circle with radius 5 centimeter, a chord is at a distance of 3 centimeter from the center. That means radius 5 centimeter. This is 5. A chord is at a distance of 3 centimeter from the center. This is 3. The length of the chord is, this is chord. This is a right angle triangle. Therefore 3, 5, 3, 5. Missing number is 4. Write this 4 here. Length of the chord is, this is midpoint of the chord. If this is value is 4, this value will also be 4. 4 plus 4 is 8 centimeter. In the given figure, this is the figure. AB is equal to 8 centimeter. Where's AB? This is 8. SC equal to 10 centimeter. This is 10. Angle ABD. ABD. This is 90 degree. And AD is equal to 17. 17. Now let's work with a bigger figure. In this figure, we have 8, 17. 8, 17. Missing number is 15. This is equal to 15 centimeter. Okay, here, let's modify this. Let's multiply its number by 2. 3 to our 6. 4 to our 8. 5 to our 10. Now let's compare this number with this figure. In the smallest figure, we have 8, 10. 8, 10. Missing number is 6. Therefore, BC must be equal to 6. We are asked to find the measure of CD. CD is equal to, from this length, subtract this part, you will get CD. CD is equal to 15 minus 6. That is 9. 15 minus 6 is 9 centimeter. That's the right answer. That's how we use Pythagorean triples in solving a problem. So you must learn by heart this combination: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, 20, 21, and 29. There are many more triples, but these are the common one. Learn by heart at least these combinations. Okay? In the given figure, this is the given figure. Triangle ABC is on isosceles triangle. Isosceles triangles mean in the given triangle, if two sides are equal, it's called isosceles triangle, in which AB equal to BC. This side, BC Before we start solving this question, first let's understand what is tangent. If a straight line touches the circle only at one point, then the straight line is called tangent of the circle. And the point where the straight line touches the circle is called point of contact. Okay? Now let's draw a circle. This is a circle. From an external point P, that means P is outside the circle. Take a point P outside circle. A tangent PQ is drawn to a circle with center O. This circle with center is O. Draw a tangent. This straight line touches this circle at this point. Therefore, it is called tangent of circle because the point where the circle and the straight line touch each other is one point. This is Q. Touching the circle at Q. If the distance of P from the center is 13, join P and O. This is 13. And the length of the tangent PQ is 12. This is 12. The radius of the circle is, join Q and O. This is radius of the circle. When we join point of contact and center of the circle, this line is always perpendicular to tangent of the circle. That's what you have to keep in mind. Now apply the triples. That's 5, 12, 13. Missing number here is 5. 12, 13. Missing number is 5. The right answer is 5 centimeters. Two circles of radius 13 cm and 15 cm intersect each other at points A and B. Radius is plural of radius. Intersect each other at points A and B. This called this A, this point B. If the length of the common chord, this is join A and B, this become common chord. This is 24 centimeter. Then what is the distance between their centers? We are asked to find the distance between these 2 points. Join A and center of the smaller circle. This is radius of the smaller circle. Smaller number is 13. Join this point with A. This is radius of the bigger circle. That's 15. Half of 24 is 12. This length is 12. Apply Pythagorean triples. 12, 13. 12, 13, missing number 5. This is 5. Modify this once again, the first line. Multiply each number by 3. 3, 3 are 9, 4, 3 are 12, 5, 3 are 15. Compare these numbers with this. 15, 12. 15, 12. Missing number is 9. This is 9. The distance between their centers is 9 plus 5. 9 plus 5, that is 14. The right answer is 14 centimeters. Two concentric circles are of radius 15 centimeter and 9 centimeter. What is the length of the chord of the larger circle, which is tangent to the smaller circle? Here, first let's explain the meaning of concentric circles. If circles have same center, then they are called concentric circles. Okay? Now, let's draw two circles having same center. Concentric circles. of radius 15 centimeters and 9 centimeters. 9 centimeter radius of the smaller one. Now draw a tangent to the smaller circle, which is again chord to the bigger circle. For this circle, this straight line is chord, and the same straight line is tangent to the smaller circle. Okay. Now, join this point with this point. That is, this line is radius of the bigger circle. Radius is 15, and this line is radius of the smaller circle. The value is 9. 9, 15, missing number. Multiply this with 3. 3 3 are 9, 4 3 are 12, 5 3 are 15. The missing number is 9, 15. 9, 15. Missing number is 12. Write this here. What is the length of the chord of the larger circle, which is tangent to the smaller circle? This is chord of the larger circle. Half of this is 12, and this side will also be 12. 12 plus 12 is 24. This is the right answer. Now let's work on this question. When you solve such problem, always write north on the top, south on the bottom, east on the right, and west on the left. Okay? Let's begin with the question. Point R is 20 meters to the north of G. That means G is at the bottom, R is on the top of G. Distance between them is 20. Point G is 12 meters to the east of point D. 12. 12 is less than 20. Point F is 16 meters to the north of D. Point A is 15 meters to the west of R. Animes is standing at the point A. He goes to point F. Now let's find the distance between AF. 15 minus 12. That is 3. 20 minus 16. That is 4. 3, 4. Missing number is 5. Then he goes to point G. Now let's find the distance between F and G. 16, 12. Missing number is, multiply its number by 4. 3, 4, 12, 4, 4, 16, 5, 4, 20. 12, 16. 12, 16. Missing number is 20. This is 20. Find the total distance covered by animes. 5 plus 20 is 25. Always take east on the right, west on the left, north on the top, south on the bottom. Rohan walk 5 kilometers towards south. 5 kilometers towards south from his house, and then 8 kilometers towards west. 8 is more than 5. 8. From this, he walked 3 kilometers towards north, followed by 4 kilometers towards east. Is 8 half. 8 half. 4. Then he walked 6 kilometers towards south. 6. 3 plus 3. 6. And 2 kilometers towards west. What is the shortest between his house and the market? We are asked to find the distance between these 2 points. This and this. Now, form a right angle triangle. Produce this. Produce this. 8 minus 4 is 4. 4 plus 2 is 6. 6 minus 3 is 3. 5 plus 3 is 8. 8, 6. Missing number is 3, 4, 5. Multiply this number by 2. 3 to our 6, 4 to our 8, 5 to our 10. 6, 8. Missing number is 10. 10 kilometers. That's the right answer.